All right, we're going to keep on moving forward and now looking at using chemical formulas as conversion factors. So what do I mean by this? Well, let's take a look at a formula and figure out how to use these formulas as conversion factors. How many moles of hydrogen are in 140 grams, I'm sorry, 14.0 grams of CH4? Now, before I get into this, let's really break down what CH4 means. Okay. If I were to ask you, if you had one molecule of CH4, how many atoms of carbon and how many atoms of hydrogen would you have? Well, that formula CH4 means that there are four hydrogen atoms and one carbon atom per molecule of CH4. Now, if I had two molecules of CH4, then I would have two carbons and eight hydrogens total, and so on and so forth. So if I had a mole of CH4, that means I would have four hydrogen atoms, 4 moles of hydrogen atoms, and 1 mole of carbon atoms per mole. Notice I'm not saying molecule, per mole of CH4. I can use this right here as conversion factors. I could say that for every mole of CH4, I have 4 moles of hydrogen atoms. Or I could say the same thing for carbon. One for every mole of CH4, I have 1 mole of carbon atoms. So with that in mind, I can use the molecular formula or the chemical formula to help me establish a conversion factor. Okay, so let's start with what we're given. We're given 14 grams of CH4. Now, according to these conversion factors up here, I need to get to moles of CH4. So I can do that if I knew the molar mass. I want grams of CH4 to cancel out, and I want to go to moles of CH4. Now, for the sake of time, I'm not going to go through that whole calculation. You do need to be responsible for it. If I'm not nice enough to give it to you, you need to know how to calculate molar mass. So for CH4, 1 mole weighs 16.043 grams. Now, this would tell me how many moles of CH4 I have. The question is asking me for moles of hydrogen. So I'm going to use the conversion factor up above that I just established. I want moles of CH4 to cancel out, and I want to go to moles of hydrogen. Well, according to the formula, 1 mole of CH4 contains 4 moles of hydrogen. So grams cancel out, moles of CH4 cancel out. The only remaining unit I have here is moles of hydrogen. And that comes out to 3.49 moles of hydrogen. Now, I'm going to take another side road here, and I want you to note something with all of these measurements, with all these conversion factors. In all these problems, both the measurements that you're given and the conversion factors you're using have 3 parts to them. Let's look at this last thing that we calculated. 3.49 moles of hydrogen. Okay, first part is the value. Okay, pretty important. Okay, you need to be able to report a value. The next thing is the unit. Okay, you can't just say I got 3.49. Well, what do you got 3.49 of? And a lot of times that those two things are not complete. As I said before, if you have 3.49 moles, what are you talking about? So at the end, you need to specify, I'm talking here about hydrogen. So that last part is what I call the subject or the object that you're talking about. So you need to indicate as part of your final answer, and I've been showing this on all the calculations beforehand that we've done in the past, I should say, that you have a value, you have a unit, and then you have something to indicate what you're talking about. What are you talking about? Copper? Are you talking about hydrogen? Are you talking about carbon? What are you talking about? That needs to be included as well. Now let's go a step further. What if the problem had said, how many grams of hydrogen are in 14.0 grams of CH4? Okay, well, I'm going to start by setting this up in the exact same way. The one thing I'm given is 14 grams of CH4. Now, I can't do any calculations to get to grams of hydrogen without going to moles first. So I'm going to use the molar mass. I want grams of CH4 to cancel out. I know that will make, or that will go to moles of CH4. So I find the molar mass. That comes out to 16.043. Notice that gives me moles of CH4. Okay, that's not what I want. I want hydrogen. So I look at the formula. The formula tells me that 1 mole of CH4 contains 4 moles of hydrogen. Okay, I'm not quite done yet because this question is asking me for grams of hydrogen. Well, I know how to go between moles and grams. I need the molar mass. So I go to the periodic table, and the periodic table tells me that 1 mole of hydrogen weighs 1.008 grams. If I've set this up correctly, all of the units cancel out except the unit I want to go to, the grams of hydrogen. And that comes out to 3.52 grams of hydrogen. Let's do another practice problem. So a packet of artificial sweetener contains 40 milligrams of saccharin. And then there's a molecular formula there. Given the molar mass of saccharin, and this problem's kind enough to give it to you. You don't have to worry about calculating it. How many molecules of saccharin are there? And then how many carbon atoms are there? Let's just deal with the first question first. Okay, so it's asking for how many molecules of saccharin there are. If I'm given the mass to begin with, the only way that you'll be able to go from anything, any mass to moles is to use molar mass. So let's start with what we're given. 40.0 milligrams of saccharin. I'll just abbreviate saccharin like that. Now, I am kind of in a little bind because molar mass is in grams per mole. I've been given milligrams. So my first step should be to convert to grams. I want to go from milligrams to grams. So milligrams of saccharin to grams of saccharin. And I know that 1 gram contains 1,000 milligrams. Okay, that's great. Now I can get to grams. Now I have to get to moles. So grams will cancel out. Moles will be on top. Now, what quantity am I going to use in this conversion factor? I want to use the molar mass. Well, the problem gave it to me. I don't have to calculate that. The problem said that 1 mole of saccharin weighs 183.18 grams. So the grams cancel out. So now the unit I have up here is moles. I'm just one step away to getting to molecules because I know the relationship between moles and molecules is to use Avogadro's number. So set up one more. 1 mole of saccharin contains 6.022 times 10 to the 23rd molecules of saccharin. So every unit cancels out until I'm left with molecules of saccharin. Toss all of that in the calculator. And I get to 1.31 times 10 to the 20th molecules of saccharin. All right. Now let's get to the last question, or the second question, I should say. How many carbon atoms are there? So now it's asking specifically about one atom in that molecular formula. So I know I'm going to have to use that formula somehow. Okay. Well, I kind of got to um, molecules of saccharin there. So I could start there, but let me just outline the whole thing. I'm going to use um, this exact same sentence here. So I'll just call that part A. Part B is going to start the exact same way. So just kind of copy and paste that. Okay, so again, that's just a carbon copy of what we did in part A. Now, because I've I've ended here at molecules of saccharin, I know that 1 molecule of saccharin contains 7 atoms of carbon. That's going to be my conversion factor. I want molecules to cancel out, and I want to get to atoms of carbon. And the conversion factor is 1 molecule of saccharin contains 7 atoms of carbon. And so that comes out to 9.20 times 10 to the 20th carbon atoms. All right, so again, the only way that you are really going to master this is to practice over and over and over.